If you want to build a real iOS app that fetches live Bitcoin prices, sends smart alerts, predicts the price, and actually uses machine learning, this video series is for you. In this series, we'll build a production-style Bitcoin iOS app in SwiftUI using model view model architecture. In this video, we will see a short demo, then we will explain core architecture, what is MVVM and why we use it. Then we will look at some examples of our project. We will discuss the project structure and start building the app. So in this video, you will create the folders and your first models. So let's start with the demo. Once you open the app, you have four main features. Click on current Bitcoin price and you will see the real-time Bitcoin price from CoinGecko API. The price is updated every 60 seconds. You can also update the price by clicking on refresh button. Next feature we will build is setting the price alert. Here you can choose the desired amount, specify your threshold, 80,000 above or below, and enable alerts. Once you save the settings, you should receive the notification on your app. Next, we will fetch the crypto news. On top here you have AI-powered daily summaries. We will use Cohere's chat API to create a short summary for each day. Below, you have a list of latest crypto news articles. Click to expand headlines and you will have access to the full article in its original website. Finally, we will use Core ML in order to predict Bitcoin price for tomorrow. You also have a graph showing your current price versus the prediction. As you see, it's a complete app with live data, notifications, AI integration, and machine learning. Now let's move to model view model architecture and see why we will use it in our app. What is MVVM and why do we use it? MVVM stands for model view model. The model is just data or classes. No UI, no API calls. The view is SwiftUI. It is what users see on screen. They render what's in the view model and handle user interaction. They contain all UI components written in SwiftUI. The view model holds the state and business logic. It observes services, prepares data for the view, and exposes published properties. They handle the logic between models and views. In this app, we will use two supporting layers. Services that are data providers. Services are responsible for getting data from outside sources, APIs, databases, or local files. They are stateless and reusable. They handle network calls, API integration, and background tasks. Managers are app-wide orchestrations that touch system frameworks. For example, notifications. This is what we will use in the Bitcoin app. Once the user sets the threshold, he will receive a notification from iOS app. So what's the difference between services and managers? A service just fetches or processes data. A manager coordinates how different parts of your app work together, often holding some state and scheduling tasks. Why do we need MVVM? First main reason is a clear separation of concerns between the user interface, which is the view, the business logic and data, which is the model, and the intermediary layer, which is a view model that manages the presentation logic and data binding. This also leads to scalability. You can add new features without breaking existing ones. Business logic in the view model can be tested without touching the UI. So this is the third reason why we use it, testability. Let's have a look at Bitcoin price flow. Once the app starts, UI shows Bitcoin price view. Bitcoin price view uses Bitcoin price view model. Bitcoin price view model calls Bitcoin price service, and Bitcoin price service hits CoinGecko API. It returns Bitcoin price. Another example from our app is the feature we have price prediction flow. Bitcoin prediction view asks Bitcoin prediction view model for predicted price. Bitcoin prediction view model uses Bitcoin prediction service. Bitcoin prediction service uses Bitcoin price predictor. Bitcoin price predictor is trained using historical Bitcoin data. We will see it later in our next videos. Another example, price alert flow. User sets an alert in price alert settings view. Price alert settings view updates price alert manager with target price, direction, above or below, and status, active or inactive. In background, Bitcoin price view model fetches price through Bitcoin price service. When target condition is met, Price Alert Manager triggers UN User Notification Center and a local notification appears. Let's look at the last example, Crypto News Flow. App starts. User opens Crypto News View. Crypto News View requests headlines from News View model. News View model calls News Service. News Service hits News API and returns News Article Array. Let's start the project. Open your Xcode and create new project. Choose the app and click Next. You can write any product name. I will write Bitcoin app. Click Next and choose the location where you want to store it. Now you have an empty project. First, let's start creating the folders. I need Managers folder, ML Models, Models, Services, ViewModels, and just Views. Now that we have all the folders we will need in the future, let's create the models. Go to the Models folder and create a new file called Models. First, import foundation. And now our first model will be Bitcoin price response. Structure, Bitcoin price response. Let's make it decodable. And we need here one attribute Bitcoin, which will be Bitcoin price. Now we need another structure called Bitcoin price. It should be also decodable and it will have one attribute, USD. What's the difference between Bitcoin price response and Bitcoin price? Bitcoin price response is a top-level JSON decoder. It represents API response from CoinGecko. Bitcoin price represents current Bitcoin price in dollars. We will have a JSON output, something like this. And Bitcoin price response maps the outer JSON with key Bitcoin. Bitcoin price maps the inner dictionary containing the USD value, which is this row. We need both of them to be decodable. Decodable is a protocol that allows Swift to construct an instance of your structure from JSON or another encoded format. It turns raw data into type-safe Swift object. In general, we will have three types: decodable, codable, and encodable. Decodable we will use only for fetching. Codable is used for saving and fetching, whereas encodable we will use only when we want to save something. The next structure we need is called market chart response. Market chart response is codable. We need an attribute prices and we define them as double. We will use market chart response for predictions. First, we're gonna store market chart response as double and later convert timestamps to date in the view model. Now let's create news article. News article is going to be codable and identifiable. We need it to be codable because we fetch JSON from News API, and codable lets Swift automatically convert that JSON into your news article structure without manually writing parsing code. Identifiable tells SwiftUI that each item has a unique ID property. This is important because SwiftUI lists need a way to know which item is which, and we need it to be identifiable for easy iteration. News article has ID, title, description, URL, and published at. News article will define as enum and make them to be coding key. Coding keys lets you map between different JSON key names and Swift property names. For example, we put case title, description, URL, and published at. if API keys differ, for example, published underscore at instead of this, we can map them without renaming your Swift variables. Next structure we need is summarized news. Summarized news are identifiable. Summarized news is a model for the AI summary. This AI summary we get back from Cohere. Since it is identifiable, we need an ID. We also need summary text and source URLs. In order to get a summary AI from Cohere, we will have to provide 3 source URLs and then get summary text. The last structure we need here is price alert. Price alert are identifiable. Price alert must be codable because it lets you serialize it to JSON or load it back easily. Target price is double. And we need 2 more attributes. We need is above. This is for our threshold. It should be Boolean because it can be either above or below. And we want to know if it's active. And of course it's also Boolean. And we don't need here the parentheses. Now we're all set. We have all models we will need for this app. In the next video, we will fetch real-time price. Like and subscribe so you don't miss the second video. See you in the next one.